We all have this innate curiosity, right? This need to understand how the universe really works at its deepest level.
Absolutely.
But it often feels like the more we learn, the more complex it gets. We make these amazing breakthroughs, and then, boom, new observations come along that seem to, well, shake things up again.
That sums it up perfectly. I
Yeah.
mean, our current models are incredibly powerful, no doubt about it.
Yeah.
But they're definitely hitting some walls.
Like with the James Webb Space Telescope.
Exactly. JWST is showing us these galaxies in the early universe that look, well, frankly, too big, too mature, too early for our standard models to easily explain.
And at the same time, you've got DSI, the Dark Energy Spectroscopic Instrument, mapping the cosmos and giving us new puzzles about dark energy.
Right. And that's on top of the big ongoing challenge, connecting quantum mechanics, the world of the very small, with general relativity, Einstein's theory of gravity for the very large. They just don't quite mesh.
It really does feel like maybe we need more than just tweaks, maybe a whole new way of looking at things.
That's the thinking behind some newer ideas.
Which brings us nicely to today's deep dive, dilation theory. It's a newer framework aiming for that unified picture, and what's really interesting is how it builds on some of Einstein's later thoughts about a kind of ether.
It's definitely ambitious. Dilation theory isn't just trying to adjust the edges. It's proposing a fundamental rethink of reality itself. Space, time, matter, the whole shebang.
So our mission for this deep dive, based on the source material Persuasive Arguments for Cosmic Unification, is to really unpack the core ideas of dilation theory.
Yeah, let's explore what it proposes, see how it tries to tackle these big mysteries in physics, and evaluate its potential.
Okay, let's get into it. The source definitely argues our current picture is incomplete. We mentioned JWST and DSI. Can you elaborate a bit more on the specific problems these observations and things like dark matter and dark energy pose for the standard model?
Well, think about those early galaxies from JWST. If gravity works exactly as we think, and the universe expanded exactly as the standard model predicts, it's just really hard to see how such massive, developed structures could form so quickly.
There just wasn't enough time.
Kind of feels that way, yeah. And with DSI, the detailed map of the cosmic web it's creating is raising questions about our models of dark energy, the stuff supposedly driving the universe's accelerated expansion.
And dark matter and dark energy themselves are still, well, mysterious placeholders, right? We see their effects gravitationally, but we haven't directly detected what they are.
Precisely. They make up, 95% of the universe's energy density in the standard model, yet remain complete enigmas. It suggests maybe we're missing something fundamental.
So dilation theory comes along and says, hold on, maybe the issue isn't just missing ingredients, but a basic misunderstanding of time and space.
That's the core idea. It suggests space and time aren't the absolute background, but they emerge from something deeper, a kind of interplay between time and gravity. And it boils this down to three key equations.
3 equations to rule them all. That's, bold. Okay, let's take the first one. The mass equation. It looks like 1 Mely black, 1 plus CN plus AG dollar. What's going on there? It's not EC2.
No, it's different. The really radical part is CP. This suggests mass isn't something a particle just has. It emerges from how that particle experiences time, specifically from temporal dilation effects.
Temporal dilation, like time stretching or squeezing.
Sort of, yeah. CP represents how a specific particle, E, experiences its own proper time flow. The idea is that different particles interact with or experience this temporal dimension differently.
And that difference is what we perceive as their different masses. What about the other bits, the T and the a taller plus NAM plus AG part?
So T is like a conversion factor, unique to each particle type. It dictates how that particle's specific temporal interaction translates into the mass we measure. That's how you get electrons being so much lighter than, say, top quarks. They just have different values, different ways of coupling to this temporal dimension.
Okay, that part makes a certain kind of sense.
And the $all plus ADIGO plus AG taller is essentially a correction factor for the environment. $80 accounts for the local gravitational potential. How strong gravity is nearby affects the emergent mass, and H value accounts for the effects of acceleration.
Wow, so a particle's mass isn't fixed. It depends on its type and its surroundings and motion.
According to this theory, yes. It's a dynamic property emerging from its relationship with the temporal dimension and its environment. A real shift from thinking of mass as just an intrinsic lump of stuff.
Definitely a shift. Okay, let's move to the second equation. The source calls it the symmetry equation, linking it to holographic principles. The equation is ADG CHAO plus Log left, right. What's the core idea here?
This one's about the deep connection between potential fields, like gravity, and the distribution of stuff density. The equation basically says how these potential fields change and evolve is intrinsically linked to the density distribution.
And the holographic part comes from?
It comes from that logarithmic term on the right, log left. In holographic ideas, information about a volume of space can be encoded on its boundary. This logarithmic relationship suggests something similar, that information about the distribution of matter and energy is encoded in a fundamental way, related to the potential fields.
So it's about how information is structured and shared between fields and matter.
Exactly. It proposes a fundamental mechanism for how information is preserved and communicates across different scales, from the tiniest quantum interactions up to the formation of giant cosmic structures. Information becomes really central.
Interesting. Information as a key player. Okay, equation 3. The cosmology equation. This one tackles the universe's expansion. Frac 1 plus S to 1.
Precisely. You know how the standard model needs dark energy to explain why the universe's expansion is accelerating?
Right, another mysterious component.
Well, dilation theory proposes this equation as an alternative. Notice that term $1 plus so again.
Yeah, the gravitational potential term from the mass equation. What's it doing here governing the whole universe?
Here it modifies the effective energy density that drives the expansion. The theory argues that as the universe evolves, the overall gravitational potential changes, and this term naturally leads to periods of accelerated expansion under the right conditions.
So, no need for dark energy as a separate thing. The acceleration just falls out of this changing gravitational landscape itself.
That's the claim. The acceleration becomes an inherent property of the universe's temporal gravitational dynamics, as described by this equation.
So these three equations together, they paint a picture where everything mass, information flow, cosmic expansion arises from what the theory calls temporal fluid dynamics.
Exactly. It's like time itself isn't just a coordinate, but have these dynamic fluid-like properties.
Temporal fluid dynamics. Okay, that definitely needs unpacking. The source talks about a fifth temporal dimension, like another time dimension, with fluid properties.
Yeah, this is where it gets pretty wild. It's not just the familiar 3 space plus 1 time dimensions. Dilation theory adds a fifth dimension, which is also temporal. And it proposes that this dimension behaves like a perfect fluid, meaning it has certain idealized characteristics.
Okay, like what are the properties of this time fluid, and how do they, create the world we see?
The theory focuses on 4 key properties. First, compressibility. Unlike our usual idea of time flowing uniformly, this temporal fluid can be squeezed or stretched. Regions can have different temporal densities.
And that connects to?
Gravity. The theory proposes that variations in this temporal density are what we perceive as gravity. It's not a force pulling things, but more like a pressure gradient in the temporal fluid. This also offers a neat explanation for the equivalence principle, why inertial mass and gravitational mass are the same.
Okay, so gravity is like buoyancy in time. Interesting. What's next?
Second property, viscosity. Like honey, this temporal fluid has a resistance to flow. The theory suggests this temporal viscosity is what sets the universal speed limit the speed of light. It might also play a role in quantum decoherence, the process where quantum weirdness fades into classical reality.
So the stickiness of time limits how fast things can travel, and maybe even explains why quantum effects are hard to see on our scale. Okay, what's third?
Third, vorticity. This one's maybe the most radical. The idea is that stable whirlpools, or vortices, in this temporal fluid are what we perceive as elementary particles.
Wait, so particles aren't fundamental point-like things, but eddies in time?
That's the proposal. And their properties, mass, charge, spin, arise from the shape, the topology of these temporal vortices, like how a whirlpool has a direction and certain stability.
That completely changes the picture of matter. Okay, and the fourth property?
Fourth is surface tension. Like water beads up, this temporal fluid has a kind of surface tension that creates stable boundaries. The theory suggests these stable conditions are what give rise to the fundamental constants of nature, the speed of light, Planck's constant, etc. Their values aren't arbitrary, they emerge from the fluid's properties.
Wow, okay, so gravity, light speed, particles, constants, all emerging from the properties of this fifth temporal dimension behaving like a fluid. The source even mentions applying fluid dynamics equations, like Navier-Stokes, to time.
Exactly. Trying to use the math we understand for water or air to describe this fundamental temporal dimension. And it's fascinating, the source quotes Einstein from 1920 saying, "Space without ether is unthinkable." He kept searching for something like this. Dilation theory offers a way to maybe make that idea mathematically concrete.
And this fifth dimension could be the bridge between the quantum world and the cosmic world. Because they seem so different, quantum is grainy, gravity seems smooth.
That's the hope. Maybe this temporal fluid behaves differently depending on the scale you're looking at. Perhaps it's more turbulent and quantized at tiny scales, leading to quantum effects, but appears smooth and continuous on large scales, giving us classical gravity. One underlying reality, different appearances.
Okay, it's a compelling, if mind-bending picture, but the proof is in the pudding, right?
Yeah.
How does this theory actually stack up against observations, like those JWST anomalies we started with?
Right, this is crucial. Dilation theory claims it can explain them. Remember the $1 plus CA dollar term in the cosmology equation? It implies variable temporal flow.
Meaning time could flow at different rates in different parts of the early universe?
Exactly. If some regions had a higher gravitational potential, time might have effectively slowed faster there, allowing structures like those big early galaxies seen by JWST to form much more quickly than in the standard uniform time model.
So the universe wasn't a level playing field time-wise. That could certainly allow for early developers. What about cosmic acceleration and the DSI results?
The same mechanism that $1 plus Sator term, modifying the effective energy density, provides a natural explanation for acceleration without needing dark energy. It's built into the dynamics. Plus, the mass equation suggests mass concentration is enhanced, where temporal dilation is greater, creating a kind of feedback loop that speeds up structure formation even more.
So regions where time flows faster attract more mass, which makes time flow even faster there, accelerating the process.
Kind of like that, yeah. The source mentions the idea of a timescape cosmology, the universe as a mosaic of regions with different temporal flows. Apparently, this timescape idea has even gotten some attention from groups like the Royal Astronomical Society as a plausible way to look at things.
And the Hubble tension, that disagreement about the universe's current expansion rate.
Dilation theory suggests that might not be a fundamental conflict. If time flows differently in different places, maybe the different measurement techniques are just probing regions with slightly different local expansion rates due to this underlying temporal variability. It could resolve the tension naturally. And the theory makes specific testable predictions about these variations for future JWST and DSI data.
So it's not just explaining old data, it's predicting new things we can look for. Okay. Now, the source also claims this goes beyond the Higgs mechanism for explaining mass. What's wrong with the Higgs picture that this tries to fix?
Well, the Higgs mechanism works brilliantly within the standard model of particle physics, giving particles mass through interaction with the Higgs field. But it has limitations, doesn't really connect to gravity. Why does Higgs mass gravitate? The mechanism doesn't say.
It operates in its own quantum world, separate from gravity's world.
Pretty much. There's also the parameter problem. You have to plug in specific values, like the Higgs mass itself, without a deeper reason why they have those values. It feels a bit arbitrary or fine-tuned. And the huge difference between the energy scale of the Higgs field and the scale of gravity, the hierarchy problem, is a massive puzzle.
And dilation theory offers its mass equation as the alternative. 1 mole its age, 1 plus Ag plus Ag.
Exactly. By saying mass emerges from temporal dilation, it inherently unifies inertial mass and gravitational mass. They're both effects of the same temporal interaction. It suggests particle masses aren't arbitrary inputs, but derived from the temporal properties.
And that environmental dependence term, 1 plus Ag implies?
It implies mass isn't absolutely constant. A particle's mass might change very slightly depending on the local gravity. That's a potentially testable prediction with hyper-accurate clocks or measurements. And the vast differences in particle masses might just naturally arise from the complex dynamics of the temporal fluid, solving the hierarchy problem without extra bells and whistles.
Could this also explain weird things like tiny neutrino masses? Or even dark matter?
The theory suggests yes. Maybe neutrinos are so light because they interact very weakly with the temporal fluid, and maybe dark matter isn't a new particle at all, but just regions where the temporal flow is distorted, creating extra gravitational effects described by that $1 plus Ag dollar term in the mass equation. Even the Higgs boson itself might be demoted. Perhaps it's just an excitation in the temporal fluid, not the fundamental source of mass.
It really ties things together if it works. Now, maybe the most speculative part in the source, connecting this to unidentified aerial phenomena, UAP. How on earth does dilation theory offer a framework for that?
Okay, deep breath here, because this definitely pushes boundaries.
Okay.
But the course looks at the reporting characteristics of UAP extreme acceleration. moving between air and water seamlessly, apparent gravitational or inertial effects, EM disturbances, even alleged time distortions, and asks, could manipulating this proposed temporal fluid explain these things?
So instead of magic, it's applied temporal fluid dynamics. How would that work for, say, the crazy accelerations?
Remember the mass equation. 1 everal, what's thing eta, 1 plus ag. If you could locally manipulate the temporal potential delage, you could potentially reduce an object's inertial mass. Less mass means that the same push gives vastly more acceleration. It might even look reactionless if the mass itself is being altered.
Okay, altering mass locally. What about zipping between air and water like they were nothing? Transmedium travel.
That could relate to the symmetry equation, the one linking potential fields and density. If you could manipulate those fundamental potential fields sufficiently, maybe you could locally negate the fluid dynamic interactions with the surrounding medium, air or water, effectively making the medium invisible to the craft.
And the weird gravity and electromagnetic effects reported?
If electromagnetism and gravity are just different manifestations of the underlying temporal fluid dynamics, as the theory suggests, then manipulating that fluid could inherently produce effects we classify as both gravitational and electromagnetic.
One mechanism, multiple effects. And the reports of time slowing down or speeding up near these things.
That fits almost too well, doesn't it? If the core idea is manipulating local temporal flow rates, then observers near such manipulation would experience time differently relative to observers farther away. It provides a potential physical basis for those subjective accounts.
It's definitely coherent, even if it sounds like science fiction. It treats UAP not as impossible magic, but as potential manifestations of advanced control over this proposed deeper layer of physics.
Exactly. The claim isn't proof, obviously, but that dilation theory offers a framework where these disparate, bizarre observations might start to make sense as related phenomena.
Okay. Moving beyond UAP, how does the theory achieve this grand unification across all scales, connecting quantum stuff to cosmic structures?
The symmetry equation is key again. It proposes universal rules for how information behaves. At the quantum scale, it dictates wave patterns and information flow. At our everyday macroscopic scale, it governs classical fields and information transfer, possibly explaining how quantum measurement works. And cosmically, that logarithmic density term helps explain how large-scale structures form from initial fluctuations.
The same rules, different arenas. And this resolves the big mysteries.
That's the idea. Dark matter effects. Could be the extra gravity from the order Ag plus Ag hour mass term in regions of altered temporal flow. Dark energy, natural acceleration from the cosmology equation, quantum entanglement's weird connection. Maybe it's information traveling through the fifth temporal dimension, bypassing our usual 3D space limits. The arrow of time, an emergent property of the temporal fluid's flow.
It paints a very interconnected universe. The source even speculates about complex systems like life and consciousness. That seems like a huge leap.
It's definitely speculative, yeah. But the logic follows the pattern.
Yeah.
If the fundamental reality is this information-rich temporal fluid, maybe living systems are just highly organized patterns, optimizing temporal flow for stability and complexity. And maybe consciousness itself is an extremely complex pattern of information processing within that fluid. It hints that biology and even neuroscience might eventually connect to these fundamental physical principles.
Dissolving the boundaries between physics, biology, maybe even philosophy. Okay, this is a massive vision. But a theory needs to be more than just a good story. What about the mathematical rigor and, crucially, testable predictions?
The force argues for the theory's mathematical elegance. It points to the simplicity of having just three core equations, how they extend existing math frameworks, their consistency, the role of logarithms echoing information theory, and possible deeper links to topology.
So it claims the math is neat, but is it testable? Can we prove it right or wrong?
That's the critical part. And yes, the theory apparently makes specific, falsifiable predictions. Things like subtle differences in the cosmic microwave background pattern compared to the standard model, specific ways the expansion history might differ, testable by looking at distant galaxies, potentially detectable modifications to gravitational wave signals, deviations from standard model predictions in high-energy particle collisions, especially concerning the Higgs or neutrinos, maybe even tiny variations in particle mass depending on the local gravitational field, which could potentially be measured with future ultra-precise atomic clocks.
So there are concrete things experimentalists could look for.
That's the claim. And beyond future tests, the theory also boasts retrospective predictive power. It naturally explains things like dark matter, dark energy, inflation, entanglement, the arrow of time, phenomena that currently require separate, often ad hoc explanations in the standard models.
offering a more unified, less bolted together picture of why the universe looks the way it does.
Exactly. More parsimonious, potentially.
All of this, especially redefining time itself as this dynamic fluid, it must have huge philosophical implications, right?
Absolutely huge. Our whole intuition about time as this steady clock-ticking background gets thrown out the window. If time is a compressible, viscous fluid with vortices, well, that reframes everything.
Like the old debates about whether only the present is real or if past, present, and future all
Right,
exist.
presentism versus eternalism. Maybe different regions of the temporal fluid correspond to different perspectives on that. Or debates about determinism versus free will. Perhaps they're just different ways of describing the fluid's behavior at different scales, one seemingly predictable, the other allowing for novelty.
And causality, cause and effect.
It might become less linear. Information propagates through this fluid, maybe in complex networks, allowing for influences that aren't just simple A causes B chains. You might get emergent, top-down causality becoming physically grounded.
And consciousness as information processing in this fluid, that's a radical take on the mind-body problem.
It suggests consciousness isn't separate from the physical, but an emergent property of the physical, specifically of information dynamics within this fundamental temporal medium. Subjective experience, the feeling of what it's like, might arise for the properties of this fluid itself.
It even challenges basic categories like substance versus process. This temporal fluid seems like both.
Exactly. Is it the fundamental stuff, substance, or the fundamental doing process? Maybe it's a third thing that our old categories can't quite capture. It really could be a paradigm shift, not just in physics, but in how we philosophically frame reality. It tries to build on Einstein and quantum mechanics, but recasts them in this new unified light. It almost brings back that Pythagorean idea, that the deepest reality is mathematical structure. In this case, the structure of this temporal fluid.
Okay, let's try to wrap this up. We've explored dilation theory, this really ambitious attempt to unify physics. It hinges on three core equations describing a universe governed by temporal fluid dynamics operating within a fifth temporal dimension.
A dimension with properties like compressibility, viscosity, vorticity, and surface tension, which the theory claims give rise to gravity, the speed of light, particles, and fundamental constants.
And it offers potential explanations for cosmic puzzles like dark matter, dark energy, those early massive galaxies, maybe even UAP phenomena, all stemming from the ability to interact with or the natural dynamics of this temporal fluid.
Plus, it proposes an alternative origin for mass, going beyond the Higgs mechanism, and makes a whole suite of testable predictions alongside its mathematical framework.
And the philosophical implications are just profound, forcing us to reconsider the nature of time, causality, maybe even consciousness itself.
The lure is that unified picture, moving away from separate theories for separate domains towards one cohesive description based on time itself being dynamic and fluid-like.
It leaves you with so much to think about. Here's a final thought to mull over. What if our intuitive feeling of time's steady forward flow is just, well, surface current? What if beneath that surface lies this incredibly complex, dynamic ocean of temporal fluid shaping everything we see? Makes you wonder what else about our perception of reality is just the tip of the iceberg.